students, myself Murali Krishna, faculty of physics. Today I am discussing some applications of Newton's laws of motion. In previous class I discussed two applications, that is motion of two bodies contacting with each other, and the second one is connecting bodies. Today I am discussing third applications, that is string pulley system. String pulley system. String pulley system. Okay, first two bodies are connected with a string. Two bodies are connected with a string. First body mass m1 and the second body mass m2. Here once again two bodies are connected with a string with the help of pulley. Here two exemptions is there, that is string is massless and inextensible. Pulley also massless. Here m1 mass is greater than m2 mass, that's why m1 mass is moving downward direction with some acceleration a, m2 mass is moving upward direction with the same acceleration a. Okay, here actually weight of the body is always acting on vertically downward direction, that's why here first body weight of the body acting on vertically downward direction, that is m1g. Here m2 body weight is acting on vertically downward direction, that is m2g. Okay, the here string is t, here also t, because of two bodies are connected with the same string, that's why two body string is t only. Okay, first body is moving downward direction with some acceleration, that's why net force acting on the first body is actually according to Newton's second law of motion, F equal to ma. According to Newton's second law of motion, force F equal to mass into acceleration. That's why here net force acting on the first body, that's why here weight of the body is more than tension force, that's why here m1g minus t is equal to m1a, that is equation number 1. Okay, second body is moving vertically above direction, that's why tension force is more than weight of the body, that's why t minus m2g is equal to m2a, this is equation number 2. Okay, adding these two equations 1 plus 2, then here m1g minus t is equal to m1g plus minus t, here plus t minus m2g is equal to m1 plus m2 into a. Okay, from here minus t plus t cancel. From this equation acceleration in a is equal to here m1 minus m2 into g by m1 plus m2. This is the acceleration of the bodies. Okay, this acceleration or substitution first equation, then you will get tension force in the string. Then from the first equation here t is equal to here m1g minus m1a, then tension t is equal to m1g minus m1 into a, means here m1 minus m2 into g by m1 plus m2. From this equation t is equal to m1 a, LCM m1 plus m1 m1 plus m2 minus here m1 square g minus m1 square g, here minus minus plus m1 m2 g by m1 plus m2, then equal to here also m1 square g, this one, here also m1 square g plus m1 m2 g minus m1 square g plus m1 m2 g by m1 plus m2. Then m1 square g minus m1 square root g cancel. Finally here m1 m2 g plus m1 m2 g. Then 2 is there now. Then tension T is equal to 2 m1 m2 g by m1 plus m2. This is a tension in the string. Okay, once again, two bodies are connected with a string. The help of pulley. Here string is massless and inextensible. Pulley also massless. Okay, here m1 mass is more than m2 mass, that's why m1 mass is moving downward direction with some acceleration a, m2 mass is moving upward direction with the same acceleration. Okay, tension in the string is T. Okay, actually weight of the body is always acting on vertical downward direction, that's why first body weight is m1 g acting on downward direction, second body weight is m2 g acting on vertical downward direction. Okay, here then you find the acceleration of the system under tension force in the string. Okay, net force acting on the first body, that is m1g minus t is equal to m1a, that is equation number 1, and net force acting on the second body, that is t minus m2g is equal to m2a, that is equation number 2. Adding these two equations, you will get acceleration. Acceleration A is equal to m1 minus m2 into g by m1 plus m2. This acceleration are substitution in equation number 1. Then you get in tension force. Tension T is equal to m1 m2 g by m1 plus m2. That is the first example. And the second, next, here also same, two bodies are connected with a string, the help of pulley. Okay, string and pulley is massless, string is inextensible. Okay, here m1 mass is more than m2 mass, that's why m1 mass is moving downward direction with some acceleration, the same acceleration m2 mass is moving from left to rightward direction. Okay, here weight of the body is always acting on vertical downward direction, that's why here m1g acting on vertical downward direction, here also m2g acting on vertical downward direction. The same force acting on vertical upward direction, that is normal force on the body. Okay, like for net force acting on the first body, that is here m1g minus t is equal to m1a, that is equation number 1, and from the second body t is equal to m2a, that is equation number 2. Okay, adding these two equations you will get acceleration. Then here m1g minus t plus t is equal to m1 plus m2 into a. Then minus t plus t cancel. Then finally acceleration A is equal to m1g by m1 plus m2. This acceleration is substitution equation number 2 from equation 2. Then tension T is equal to what is that? Already m2 is there. A means here m1g by m1 plus m2. Finally tension m1 m2 g by m1 plus m2. This is a tension in the string, this is the acceleration of the body. Once again, two bodies are connected with the string, the help of pulley. Okay, here m1 mass is more than m2 mass, that's why m1 mass is moving downward direction with some acceleration, m2 mass is moving rightward direction from left side. Okay, here tension in the string is T, the body is moving downward direction with some acceleration. Then you find the tension force in the string and acceleration of the bodies. Okay, net force acting on the first body, that is m1g minus t is equal to m1a. Then next net force acting on the second body, this is acting on outward direction of the tension force, there is no left side direction, that's why t minus m2a. Adding these two equations you will get acceleration, that is a is equal to m1g by m1 plus m2. This acceleration are putting in equation number 2, then you will get into tension, that is t is equal to m1 m2 g by m1 plus m2. That is the second example. And third one is okay, here three bodies are connected with a string, the help of pulley. This is mass m1, this is mass m2, this is mass m3. Okay, in this tension force here in this T1, because of these two bodies are connected with the same string. Okay, here tension force is T2. Okay, here first weight of the body always acting on vertically downward direction, that is m1g. Here also weight of the body always acting on vertically downward direction, that is m3g. Here also weight of the body always acting on vertically downward direction, that is that is m2g. Okay, here the first body, these two bodies are moving downward direction with some acceleration a. This m1 body is moving upward direction with some acceleration a. Then net force acting on the first body. The first body is moving vertically upward direction. That's why tension force is more than weight of the body. That's why here T1 minus m1g is equal to m1a. That is equation number 1. Next here second body, the second object is moving downward direction. That's why weight of the body acting on vertically downward direction, tension force T2 also acting on vertically downward direction. That's why here T2 plus m2g minus T1 is equal to m2a. That is equation number 2. Next third body, weight of the body acting on the downward direction. That's why m3g minus T2 is equal to m3a. That is equation number 3. That is 3 net force acting on your 3 bodies. Then adding these 3 equations, 1 plus 2 plus 3, then T1 minus m1g plus T2 plus m2g plus m3g minus T2 is equal to m1 m2 m3, means m1 plus m2 plus m3 into a. Then here minus T2, wait, here also here is something one, what is that? That is T2 plus m2g minus T1 plus m3g minus T2 is equal to m1 plus m2 plus m3 into a. Then here T plus T1 minus T1 plus T2 minus T2 cancel. Here finally here m3g, here m2g, here m2g plus m3g minus m1g is equal to m1 plus m2 plus m3 into a. Then acceleration, finally acceleration a is equal to m3 plus m2 plus m3 minus m1 into g by m1 plus m2 plus m3. This is acceleration of the bodies. This acceleration of the bodies. This acceleration substitution any equation will get T1, and the acceleration is substitution any third equation we will get to T2. Okay, from all are understood. Once again, 3 bodies are connected with a string, the help of pulley. Here pulley and string is massless, string is inextensible. Okay, here 3 bodies mass is m1 m2 m3. Okay, here m1 m2 m3 mass is moving downward direction with some acceleration a. Here m1 mass is moving upward direction with acceleration a. Okay, here T, here also tension T. Say these 2 bodies are connected with the same string, that's why tension T. In the string tension is T2. Okay, weight of the body is always acting on vertical downward direction. That's why 3 bodies weight is acting on vertical downward direction. First net force acting on the first body, that is T1 minus m1g is equal to m1a. That is equation number 1. Next to m3g, here T2 plus m2g minus T1 is equal to m2a. That is net force acting on the second body. And m3g minus T2 is equal to m3a. This is the net force acting on the third body. Okay, then adding 3 equations, that then you get acceleration a is equal to m2 plus m3 minus m1 into g by m1 plus m2 plus m3. Okay, this acceleration or substitution equation number 1, then you get into tension force T1. Okay, this acceleration or substitution equation number 3 will get to, or you will get tension T2. Okay, acceleration ఇక్కడ రాసి చూడండి, a is equal to m2 plus m3 minus m1 into g by m1 plus m2 plus m3. Okay. Okay, from equation number 1, then T1 is equal to here m1g plus m1a. Then T1 is equal to m1g plus m1a means here m2 plus m3 minus m1 into g by m1 plus m2 plus m3. Okay, from this equation tension T1 is equal to, okay, LCM is m1 plus m2 m plus m3 na. There is cross multiplication here. చూడండి m1 plus m2 plus m3 into m1g plus here m1 m2g m1 m2g plus m1 m3g m1 m3g minus m1 square g m1 square g by m1 plus m2 plus m3. Then tension T1 is equal to, here also m1 square g plus m1 m2g plus m1 m3g. Next plus m1 m2g plus m1 m3g minus m1 square g by m1 plus m2 plus m3. Here m1 square g minus m1 square g cancel. Finally tension force T1 is equal to m12 minus 2 m1 m2 g 13 plus 2 m1 m3 g by m1 plus m2 plus m3. That is the tension force T1 in string. Next from equation number 3 from equation number 3, okay, here T2 is equal to m3g minus m3a. Then T2 is equal to m3g minus m3 into a means already m2 plus m3 minus m1 into g by m1 plus m2 plus m3. Okay, from this equation T2 is equal to cross multiplication m1 m3g plus m2 m3g plus m3 square g minus m3 m2g plus minus here m3 square g minus plus m1 m3g by m1 plus m2 plus m3. Then tension T is equal to, here plus m3 square g minus m3 square g cancel. Finally m1 2 3 got it, that's why 2 m1 m2g. Here m1 m3g, here m1 m3g means 2 m1 m3g plus here m3 2g minus so m1 m3g 2 m1 m3g plus here 2 3g means here once this 2 also cancelled. Here m2 m3g finally will get by m1 plus m2 plus m3. This tension force in the string. Once again, 3 bodies are connected with the string with the help of pulley. Pulley is massless and inextensible. String is also massless. Okay, 3 bodies weight is always acting on vertically the downward direction, that is m3g, m2g, m1g. Okay, tension in the string is T1. Here tension is on the string is T2. Okay, here m2 m3 mass is moving downward direction with some acceleration, m1 mass is moving upward direction with some same acceleration. Okay, net force acting according to Newton's second law of motion, F equal to ma na. That's why net force acting on the first body, that is t1 minus m1 equal to m1a. Next, net force acting on the second body, that is T2 plus M2G minus T1 is equal to M2A. Next force acting on third body, that is M3G minus T2 is equal to M3A. Okay, adding these three equations, we will get acceleration, that is acceleration A is equal to M2 plus M3 minus M1G into M1 plus M2 plus M3. This acceleration are substitution equation number 1. Then you get into tension force T1. T1 is equal to M1 M2G plus 2 M1 M3G by M1 plus M2 plus M3. Okay, next to this acceleration are substitution equation number 3. Then we will get into tension force T2. T2 is equal to M1 M3G 2 M1 M3G by M1 plus M2 plus M3. This is a tension in the string here T2. This is T1. This is acceleration. All are understood? Next. Next one. This is M1, this is M2, this is M3. Tension in here T1, here also T1, here T2, here also T2. Okay, here weight of the body is always acting on vertically downward direction. Actually, three bodies are connected with string with the help of two pulleys. Okay, here m1 mass is moving downward direction with some acceleration a, m2 mass is moving rightward direction with some acceleration a, here m3 mass is moving upward direction with some acceleration a. Okay, from these three equations, from these three bodies, weight of the body is always acting on vertically downward direction. That's why here m1 mass is moving downward direction, that's why here actually net force acting on the first body, that is net force is here, right here m1g minus t1 is equal to m1a, that is equation number 1. And the next body, second body is moving rightward direction, means t1 force acting on this direction, t2 force acting backward direction. That's why t1 minus t2 is equal to m2a, that is equation number 2. And m3 body is moving upward direction, that's why t2 minus m3a m3g is equal to m3. Yeah, this is equation number 3. Adding these three equations, then you get into acceleration. Okay, adding m1g minus t1 plus t1 minus t2 minus plus t2 minus m3g equal to m1 plus m2 plus m3 into a. Here minus t1 plus t1 minus t2 plus t2 cancel. Final acceleration a is equal to, okay, here m1g minus m3g by m1 plus m2 plus m3. This is acceleration of the bodies. Next, this acceleration are substitution equation number 1, then you will get into tension force T1. And this acceleration are substitution equation number 3, then you will get into tension force T2. Then from this equations, show here from equation number 1, T1 is equal to m1g minus m1a. Then T1 is equal to m1g minus m1 into a, means here m1g minus m3g by m1 plus m2 plus m3. Okay, from this equation T1 is equal to, adding this one here, m1 square g plus m1 m2g plus m1 m3g minus m1 square g plus m1 m3g by m1 plus m2 plus m3 plus m1 square g minus m1 square g, both are cancelled. Then next equation equal to m1 m2g, then m1 m2g plus 2 m1 m3 g by m1 plus m2 plus m3. This is the tension in the string. Okay, next to this acceleration substitution equation number 1, then your tension T1 is equal to here m1 m2g plus 2 m1 m3g by m1 plus m2 plus m3. Okay, from equation number 3, T2 is equal to m3g plus m3a, then T2 is equal to m3g minus m3 into a means here m1g minus m3g by m1 plus m2 plus m3. Okay, then T2 is equals to cross multiplication here m1 m3g plus m2 m3g plus m3 square g plus m1 m3g minus m3 square g by m1 plus m2 plus m3. Okay, here plus m3 square g minus m3 square g cancelled, then finally tension T2 is equal to 1 3 2 m1 m1 m3g m1 m3g means 2 m1 m3g plus m2 m3g by m1 plus m2 plus m3. Once again, 3 bodies are connected with a string the help of pulley, 2 pulleys. Okay, this is the total outlook of the diagram. Okay, net force acting on the first body, this one only. Net force acting on the second body, this equation. Net force acting on third body is this equation. Okay, adding 3 equations, then you will get into acceleration. Means what you can find out the acceleration of the system under tension force T1 and tension force T2. Okay, adding these 3 equations, then you will get into acceleration. This acceleration putting in equation number 1, then you will get into tension force T1. T1 equal to m1 m2g plus 2 m1 m3g by m1 plus m2 plus m3. Okay, this acceleration or substitution equation number 3, then you will get into tension T2. T2 is equal to m1 m3g plus m2 m3g by m1 plus m2 plus m3. This is another example. Next, well, this is theta is angle of inclination. Okay, on this is string. This is m1 mass, this is m2 mass. Okay, tension in the string is T, here also T. Okay, here m1 mass is moving downward direction with some acceleration A, m2 mass is moving upward direction with some acceleration A. Here weight of the body acting on vertical downward direction, that is m1g. Here also weight of the body acting on vertical downward direction, that is m2g. Okay, normal force acting on the body is perpendicular to the surface, that's why this is a normal force. Okay, this angle is same, that is theta. Okay, this weight of the body acting on this weight of the body resolving the 2 component. One is the along the inclination, that is m2g sin theta, perpendicular to the inclination is m2g cos theta. This is the outlook of the diagram. First, net force acting on the first body, that is here m1g minus t is equal to m1a, that is equation number 1. Next to here second net force acting on a second body, T minus m2g sin theta is equal to m2a, that is equation number 2. Adding these 2 equations, then you will get into acceleration. Then here m1g minus t plus t minus m2g sin theta is equal to m1 plus m2 into a. Here minus t cancel. Finally acceleration a is equal to m1 minus m2 sin theta into g by m1 plus m2. Okay, this acceleration or substitution equation number 2, then you will get into tension. Then from equation number 2, T is equal to m2g sin theta plus m2a. Then tension T is equal to m2g sin theta. LCM already write down directly, m1 plus m2 plus m2, a means here m1 minus m2 sin theta into g by m1 plus m2 plus m3. Final tension T is equal to here m1 m2 sin theta total common g plus m2 square g sin theta plus m1 m2 minus m2 square sin theta g all whole common by m1 plus m2 plus m3. Okay, here m2 square sin theta m square sin theta cancel. Finally tension T is equal to m1 m2 common, then 1 minus sin theta into g by m1 plus m2 plus m3. This is the tension in the string. Once again, two bodies are connected with a string, the help of pulley on inclined plane. Okay, first body is moving downward direction with some acceleration a. M2 mass is moving upward direction with some acceleration a. Tension in the string is T. Okay, here weight of the body acting on vertically downward direction, that is m1g. Here also weight of the body acting on vertically downward direction, that is m2g. Okay, this weight of the body is resolving into two components, that is along the inclined plane is m2g sin theta, perpendicular to the inclination is m2g cos theta. Okay, normal force acting on the perpendicular to the surface. Okay, net force acting on the first body, that is m1g minus t is equal to m1a, that is equation number 1. Okay, net force acting on the second body, that is t minus m2g sin theta is equal to m2a. Adding these two equations, then you get into acceleration, that is a is equal to m1 minus m2 sin theta into g by m1 plus m2. This acceleration or substitution equation number 1 or 2, then you will get into tension T is equal to m1 m2 into 1 minus sin theta into g by m1 plus m2 plus m3. Are understood? Next final example. Last final example is alpha, this angle is beta. Here pulley, this is m1 mass, this is m2 mass. Here tension is T. Okay, already you know, here in this direction m1g sin alpha, in this direction is m2g sin beta. Okay, m1 mass is moving downward direction with some acceleration, m2 mass is moving upward direction with some acceleration a. Then net force acting on the first body, that is m1g sin alpha minus t is equal to m1a, that is equation number 1. And net force acting on the second body, that is t minus m2g sin beta equal to m2a, that is equation number 2. From equation 1 and 2, adding these two equations, so here m1g sin alpha minus t plus t minus m2g sin beta is equal to m1 plus m2 into a. Finally minus 2 plus t cancel. Finally acceleration a is equal to here m1 sin alpha minus m2 sin beta into g by m1 plus m2. Okay, any this acceleration or substitution any equation, then we will get into tension. From the equation number 2, T is equal to here m2g sin beta plus m2 into a means here what is this, m1 sin alpha minus m2 sin beta into g by m1 plus m2. Okay, from finally LCM m1 plus m2 na, then here m1 m2 sin beta plus m2 square sin beta Here G is whole common plus M1 M2 sin alpha minus M2 square sin beta into G by M1 plus M2. Then tension T is equal to M2 square sin beta, M2 minus M2 square sin beta cancel. Finally here M1 M2 common. Then finally here tension T is equal, finally tension T is equal to M1 M2 common sin alpha plus sin beta into G by M1 plus M2. This is the tension. Interesting. Once again, here two bodies are connected with the string the help of pulley on two sides inclined plane. Okay, this is alpha is angle of inclination in this side, beta is angle of inclination in this side. Okay, here M1 mass is moving downward direction with same acceleration. Here M2 mass is moving upward direction with same acceleration. Okay, net force acting on the body. Actually, weight of the body acting on vertical downward direction, that is M1G. Then M1 is resolving to two components, that is M1G sin alpha along the inclination perpendicular to the inclination is M1G sin cos alpha. That is no need, that one will take this moving in this direction, and that's why M1G sin alpha here, M2C sin beta here, angle of inclination is beta, not that's why sin beta. Okay, net force acting on the first body, that is M1G sin alpha minus T is equal to M1A, that is equation number 1. Net force acting on the second body, T minus M2G sin beta equal M2A. Adding these two equations, then you will get into acceleration A is equal to M1 sin alpha minus M2 sin beta into G by M1 plus M2. Okay, this acceleration or substitution equation number 2, then we will get into tension in the string. T is equal to M1 M2 sin alpha plus sin beta into G by M1 plus M2. Okay, all are understood?